Okay, in the last video, you were taught how to solve systems of linear equations using graphing. Graphing has definitely some advantages in the fact that it's very visual. You can see exactly what's happening. The disadvantage is if it does not cross at an exact point. Say, for example, that it crosses at x equals 1, y equals 2.33333. You're not going to be able to perfectly determine that. So the advantage to solving systems of linear equations by substitution, the advantage of substitution is that we will always get an exact answer. Substitution yields an exact answer. Okay. Means if we get that it crosses at 1/3 or 2/3 or whatever, that's okay because we know exactly where it's going to cross. Now, evaluation, this is just a recall. So evaluation is simply the process by plugging in values of a variable that we know. For example, if I know that I have an equation, say that's 2x plus 3y equals 4, and I know that y is equal to 2, that means that I can take that 2 and I can replace y with it, and the beauty of that is that now that I've made that replacement, I've only got one variable. Well, if I've only got one variable, that means I can solve for that variable, okay, right? Because I can just multiply this to get 6, subtract it from both sides, divide by 2, and I know what x is. If I have two equations and two unknowns, then I can simply solve for one of them, plug it back in, and solve for the other. Okay? So that's going to be my steps that I'm going to use with substitution. They are as follows. First, solve for one variable in either equation. Okay, it does not matter what. There are some good rules of thumb here. The first is that you will probably want to solve for a variable that's already isolated. We'll go over one of those here in just a minute. Another option is try to solve for a variable that does not have a coefficient, because that's going to give you a non-fractional answer. There's no division that has to take place, so you won't get a fraction. Okay, so there are a couple of things that you should keep in mind when solving for that variable. Okay, once that variable is solved for, you're going to plug that in, so plug in that answer, into the other equation. I'm going to underline that because that's very, very, very important. Don't plug it into the same one, because then you're going to get an infinite number of solutions, because you're basically working with the same equation, but you're going to plug it into the other equation. 3. Once you do that, you're going to solve for the variable. And here, on this step, I'm going to get, say, x equals 2 or y equals 4. Some version of y that is, or x that is going to be a whole number. So you're going to solve for the variable there, and then you're going to plug that answer. So plug in your step 3. You're going to plug in step 3 into either equation. Okay, and then you're going to solve again. And you're going to solve for that variable. Solve for the variable. Okay, so there are 3 types of solutions you're going to get. So types of answers. The types of solutions you're going to get are, first, just like graphing. Now, let me be clear that substitution, you're doing the same thing as you were with graphing, in that I'm looking for the point in which the 2 lines are going to cross, so the 2 systems cross. So you could have any of the same solutions that you would have had with graphing. The first one is one solution. And you know you're going to have one solution if you ever are solving. If you're ever solving and you get x equals 3, plug in and get y equals some number. That's going to give you a Cartesian point. The second is going to be no solution. You're going to know that it's going to be a no solution if you get something in the end that's not true. Let's say, for example, you get 24 is equal to 36. Well, that's obviously not true, right? In fact, I'm going to put this line right here saying that it's not equal to that. That's going to indicate that there's no solution. It means that there's no relationship between the 2 lines. It means that they're parallel. And then 3, the other one is going to be infinite number of solutions. Which means that they're going to be the exact same line, and I'm going to have full equality. So, for example, 24 is equal to 24. Well, that's always true. So the 2 lines are identical, and you're going to have an infinite number of solutions. So let's go ahead and work a few examples, and you'll have my lecture for this section. Okay, so first example is as follows. So I've got this system of linear equations. I've got one line here and one line here. And I've got to make the decision, because remember, I can solve for any variable I want. So technically I could come down here and I could solve for y, I could solve for this y, either one. I could solve for this x for that matter. But notice if I solved for this x, I'd move the y over, I'd divide by 3, and then I would get a fraction. I don't want that, so I need to be a little discerning while I work on this to determine which one I want to solve for. This one is almost completely solved for. I can see if I divide by a 4, I'll get a 2 and a 3, no fraction. So I really like this equation to start my solving. Okay, now let me be clear, you could have solved down here and been just fine if you wanted to. So I'm going to call that my red equation, and so I've got 4y is equal to 8x plus 12. This is the first equation that I'm going to work on. And remember, the first step is to solve for any variable. I'm going to choose y here because it's easier, but I could have solved for any variable. So what I'm going to do now is I'm going to divide by my 4 because I've got to solve for y. I want to know what y is. So I'm going to divide all of these by 4. And what that's going to do is it's going to leave me with y is equal to 2x plus 3. Okay. Well, that tells me what y is. It says that y is 2x plus 3. That means anywhere I see a y, I can plug in 2x plus 3. Well, that's a very, very strong that's a very, very strong piece of information, because that means that I can replace y with an x, okay, and then I'm going to have one equation with only one unknown that I can solve. So I'm going to take that 2x plus 3 and I'm going to plug it in to the other equation. That's going to be the important part. I'm going to plug it into the other equation. So I'm going to take this and plug it in. So I'm going to call that my blue equation. So this is going to be 3x plus, plug in my 2x plus 3, plug in that full binomial, and that's going to be plus, I'm going to put it in parentheses just because it makes me feel better. if this were a minus, I would have to distribute the minus, so I like putting it in parentheses, is equal to negative 7. Well, since this is a plus, I can just drop my parentheses, no big deal. So this is 3x plus 2x plus 3 is equal to negative 7. Well, 2 and 3x, 2x plus 3x is equal to 5x. Now this is just a linear equation that I know how to do. So I'm going to subtract my 3. It's going to give me 10, or negative 10. So this is 5x is equal to negative 10, dividing by my 5. I'm going to get that x is equal to negative 2. Now at this point, I know I have one solution, because when I'm given a point here, I know that negative 2 is my x value, and I just need to know what my y is. Well, I determine what my y is by plugging in my x anywhere I want and then solving. Now, it doesn't matter if you plug it into the top or the bottom. Okay. It did matter whenever I dealt with my first equation. I had to plug it into the other. But now that I found a number, I can plug it in anywhere I want to. So, just for simplicity of drawing arrows' sake, I'm going to go ahead and plug it into the bottom one. Again, it doesn't really matter. So, this is going to be 3 times the negative 2 that I had solved for, plus y is equal to negative 7. Well, 3 times negative 2 is negative 6, plus y equals negative 7. Add 6. So that's going to give me that y is equal to negative 1. So that tells me that my point of intersection, the point in which both of these lines cross, there is one solution, and that solution is the point negative 2, comma, negative 1. And there's my answer. So I have one solution, and that solution is the point negative 2, negative 1. Okay? Moving on to another.